Hello everyone. Today in this video we are going to study detail about foundations. This is the topic which will comes under the module 2nd of building material and construction. So basically every structure consists of two parts. So first one is the substructure of foundations and second one is the superstructure. So coming to the foundation, it is the lowest part of a structure which is constructed below the ground level. Means I think you people have seen while constructing any structures like a building or any compound wall. So first we are going to excavate the earthwork. Okay, so for a required depth we are going to excavate, and in that the excavated earth we are going to place the concrete, that is PCC. Then after that we are going to construct the foundations or one structures. So that constructed structures we are going to call it as a foundation. Okay, so that is the lowest most structures of the means lowest most part of the structures. Okay, so which is constructed, or we can say like that the structures which is constructed underground is known as the foundations. Okay, then the functions of foundation is to transmit the weight of a superstructure to the subsoil. Oh yes, so basically our structures consist of substructure, superstructure. In superstructures mainly slab, beam, column. Okay, so whatever the load is applied or coming on the slab, that slab will transfer to the beam, and after that the beam will transfer to the column, and after the column the whole load will be transferred to the foundation. Then ultimately foundation is the last part of the structures which will transfer whole load of the structures to the earth ground. Okay, so this is the main function of the foundation. Then coming to the types of foundation, there are two types. First one is the shallow foundation and second one is the deep foundation. Okay, so here I have mentioned shallow foundation, the foundation which having the depth is less than or equal to the breadth, that will be the shallow foundation, less than or equal to the breadth. Here I am showing you one figure. So this is the ground level of the this represents the ground level. So in that ground level we are going to excavate it. This is the excavated earthwork, or in that is the excavated earthwork we are going to construct the foundation. So whole portion from here to here we are going to call it as a foundation. So this is my breadth and this is my depth of the foundation. If my depth of foundation is less than or equal to this breadth of foundation, so we are going to call it as a shallow foundation. Okay, next coming to the deep foundations. So if my depth is greater than or equal to the breadth is known as deep foundation, means depth will be greater than this breadth. Suppose if 1 meter breadth is there, then my depth will be 1.2 or 1.3 meter in case of deep foundation. But in the shallow foundation 1 meter by 1 meter we are going to use. Okay, so that is the shallow foundation. So types of foundation, coming to the types of foundation, once again in the shallow foundation and deep foundation classifications are done. So in that shallow foundation, first one is the wall foundation, isolated column foundation, combined foundation and mat or wrapped foundation. So in the deep foundation, pile foundation, under rimmed pile and well foundation. Okay, so these are the some types which will comes under the shallow foundation and deep foundation. So this is the shallow foundation, which means wall foundation will comes under the shallow foundation. Okay, so this is the example of wall foundation. So this is the earthwork, so this is the ground level of the earth and this is the excavated area. So in that excavated area the sand or precise of a bricks, means first bed we are going to prepare, because sometimes uneven surface are there. So to have a even surface and to have a more bearing capacity we are going to prepare the bed by compacting or by placing some other what we are called by hammering also. This is the hammering. Why hammering we are using? For the compaction purpose. Okay, so bed foundation we are going to prepare, and after the once the bed foundation is prepared, then we will start the constructing the wall. Okay, so wall foundation, this is the example. So wall foundation here, see, so here first at a required depth we are going to place the PCC. It's a plain cement concrete, it doesn't contain reinforcement. Okay, only plain cement concrete. Plain cement concrete means it contains aggregate, coarse aggregate, fine aggregate and cement and water. Now, so mixture of these four we are going to place here. So it is called it as a PCC, plain cement concrete. After that, in over this bed we are going to construct the wall. Okay, so this is the simple wall foundation, and here this is the stepped wall foundation. Means at a required depth some 0.5 mm we are going to 0.5 mm we are going to place the PCC. Then we are going to construct one layer of brickwork. This is the first footing. After that, second footing. After that, plinth. Next, this will be our wall. So this is the stepped footing. Okay, so these are the some examples of wall foundation. So isolated footing, coming to the isolated footing, it is provided under column to transfer the load safely to bed soils. Okay, isolated footing is nothing but here we are going to provide under directly wall. Okay, this is the wall, not column. This portion is the wall, not column. Okay, directly we are going to placing the footing, or once the footing is finished, immediately we are constructing the wall. Okay, but in the isolated footing, what we are going to do? We are going to do first place the PCC. After that, we are going to construct the reinforced columns. Okay, then after that we are going to construct the superstructures. Okay, so this footing may be slab, stepped or sloped ones. Okay, so this is the one example how they are going to carry out the work in the practical way. So we are going, this is the excavation of the earthwork. Okay, so first they will excavate for a required depth, then they are going to construct the footings by using the concrete or RCC or brickwork. Okay, these are the some workers involved while placing the concrete in the footings. So this portion will be column. Okay, so it will exist from the footing. So here coming to the isolated footing. So in the isolated footing, what we are going to do? So in the isolated footing, what we are going to do? We are this is the ground level representing. Here it is the ground level. So first PPC, then first footing. It is in a sloped way. Okay, so we are going to place directly. Sometime we are going to use a reinforcement also inside this. Okay, and in after the reinforcement, centering will be done. Then after that we will place the concrete. Okay, so coming to the combined footing is the one which supports two columns, and it may be rectangular, trapezoidal in plans. Means if we are going to place if bearing capacity of the soil is low, then what we are going to do? We are going to place the footing. Means their spacing between the two footing is very less. That time we are going to place the combined footing, means side by side. Okay, so if the distance between the two footing is very less, that time we are going to prepare the combined footing. Okay, so that combined footing we are going to place in terms of rectangular or trapezoidal in plan. The aim is to get uniform pressure distribution under the footing. For this, the center of gravity of the footing should coincide with the center of gravity of the combined load of the two columns. Okay, then combined footing are used in the following situations: when the column are near to each other so that their footing overlap, when the bearing capacity of the soil is less, requiring more area under the individual footing, and when the end column is near a property line so that its footing cannot be spread in that direction. So this is the image of combined footing. So this is the rectangular combined footing, and this is the trapezoidal combined footing. This is the one column and this is the second column. Okay, this is one column and this is second column. By combining, we are going to place the only one footing. Okay, so this is the combined footing. Next, mat foundation. So it is the most suitable foundation when the soil at the site proposed for the construction of structure is erratic, soft clay, made up of ground or marshy land with a low bearing capacity. So when we are going to prepare the mat foundation is nothing but like a slab. Okay, in the slab we are going to place the number of columns, so that will be our mat foundation. Okay, so for number of column only one footing is there, so that will be our mat foundation. So when we are going to place the mat foundation, if our soil is marshy land or soft clay or erratic, means it consists more porous, it is it having more pore in nature. Okay, then it also have the low bearing capacity. So mat foundation is constructed of RCC slab covering the whole area of the bottom of the structures. The slab is provided with a steel reinforcing bars in both directions. When column loads are heavy, the main beams and the secondary beams are provided monolithically with the wrapped slab. So this is the image of slab, mat footing or wrapped footing. Okay, this is the cross sectional and this is plan. Okay, mat foundation. So here 1 2 3 4 columns are placed, and these are the secondary horizontal beams. Okay, so each horizontal beams is connected 1 or 2 columns, and this is the column section. Okay, so this is the image of mat foundation. Then coming to the file foundation, the file foundation is more commonly used in a building construction. So whatever up to the mat foundation, we people have studied shallow footing. So this comes under the deep footing. So pile foundations is more commonly used in a building construction. Pile foundations are used in the following situations. The load of the superstructure is heavy and its distribution is uneven. When we are going to use the file foundation, come sir. When you are going to use the file foundation, if the load which is coming on the structure is very high and whatever the load is distributed to the earth ground is uneven, so that time we are going to use the file foundation. So topsoil has poor bearing capacity, so this is the one of the reason why we are going to use the file foundation. Okay, then if the subsoil water level is high, okay, so if subsoil water is high, what will happen? Bearing capacity, it will affect the bearing capacity of the soil. To reduce that thing, we are going to use the file foundation. So these are the some types of file foundations here. So in the classification, it is based on the functions. So in that file foundation, first one the friction files, then compaction files, tension files and anchor files. Next is classification of files based on the material and compositions. Okay, what kind of materials you are going to use. So depending upon those materials, once again the files are classified. So here H files, okay, pipe files and sheet files, or timber files, steel files, okay, or concrete files. These are the some files which are classified based upon their material of constructed. Okay, so in that first one,